So, after lunch, we need something more interesting than usual after lunch talk. Then everyone tries to fall asleep. So we will speak about interesting things today. And those interesting things are PostgreSQL worst practices. So briefly about myself. My name is Ilya. I'm working for DataEgrid. We do consultancy with Postgres. And that's actually the source of the worst practices I would explain here. Besides of that, I do some things in community. I'm on PostgreSQL sponsors committee. I was on Code of Conduct committee for some time, and I'm on the board of directors of PostgreSQL Europe. So, PostgreSQL worst practices. Best practices are simply boring because if I tell you do like this and do like that, well, it's obvious. You know that already, so nobody would be listening. And besides of that, never follow best practices. Try worst practices instead. And only worst practices can actually help you to achieve the maximum damage on your system. I checked this before. That's not just words. With some of those worst practices, you really can screw things up. And besides of that, if you follow worst practices, you make PostgreSQL consultants happy. And those are good people. We like going for conferences, talking, and so on and so on. So basically, we appreciate if you follow those worst practices. How it works? So I have a little bit more than 100 worst practices, just like single items. Of course, there is no way to fit them into a single talk. Probably I already can do the entire day training on worst practices, but it would be maybe too much. So that's not stuff which is made up, just real cases, anonymized mostly. But you can count actually. Did you ever try to implement those things yourself? Sometimes I would say many of them at some point I did myself, but most of them I'm collecting them. So I reshuffle all those worst practices to get 20, sometimes 30 to present to you. I have a Perl script. It's worst practice thing. You do not write a script for worst practices in Python or C or something like that. It's Perl script, which I use to collect that into the presentation right before the talk, which I did. To be completely honest, some of worst practices are connected between each other, and I prefer some of them and always include them, so it's like not entirely fair shuffle. So basically, some of them I add manually. But anyway, let's demonstrate how it works. So the test worst practice recipe. Do not use indexes. Why you should use indexes? Basically, there is no difference in speed of access between sequential scan and index. You do not need to use any index. And you can easily prove that. Just use your laptop, 10 rows, insert, try to use explain, analyze. Nothing changes. So nobody deals with more than 10 rows in production. Never, ever, that doesn't happen. So you see how it works. It was the training one. Or another training one. So do not allow your software developers in your team. So basically, who considers themselves as DBA here? And who is a developer? Now you understand from both sides. So never, ever allow the developers to the production. Security is important. Your developers write code. They never see it working. And if anything happens, operations would be blamed that things go wrong. Developers have no connection to that. It's super efficient. Everything will be definitely very bad. But besides of that, that improves team interactions and so on. So everyone like each other. Developers blaming operations, operations blaming developers. Win-win situation. So from this simple worst practice, you can gain multiple benefits. Well, that was like training 2. Now let's go to the proper ones. First, use ORM, always. Complexity of your queries, workload, doesn't matter. All the databases, remember, share the same syntaxes of queries. So ORM, that's a good thing. You must write database-independent code because, everyone changes a database in the project every day. So basically, you start with MySQL in the morning, then you switch to PostgreSQL and end up in DB2 on system Z. That's normal. And besides of that, that's an extra layer of complexity. It's good to learn new technology, for God's sake. So use ORM, it's always good. Use as many count as you can, especially if you're writing something like heavy loaded internet site, website. Or on the main page of such a website, some statistical counter of that size would be very informative. Even if the user reloads the page, it changes to something completely different. So select count is very important. Besides of that, this query is very light. So basically, Postgres can handle select count almost instantly. Any size of table, any workload, do that. Any sort of estimation from PG catalog is not reliable enough. And besides of that, it doesn't screw up the performance. So use as many counts as you can. Move joins into the application. Because, software developers usually like the languages they use. So basically, I like Python. Why I do joins in SQL? Because Python is much more powerful. I can load everything into memory. Then I can join at the application level. Now I need to re-implement nested loops algorithm, hash join algorithm, merge algorithm, and basic optimizer to choose between them. So you can experiment yourself. So basically, you write a join, so it's like a couple of lines of SQL code, but then write join in your favorite programming language. You will see how efficient it is. So just do it. Be in trend. Be schemaless. Schema is a very old thing from the mainframe era of big banks and so on. Today, nobody has any interest in schemas. So you need basically 2 columns, ID and extra. Extra you can put in JSON. So we are modern people. We do not use XML. We use JSON. And JSON in Postgres is very efficient. JSON-B type is really efficient. And even if you put 1 million rows in this JSON field, it would work as expected. And even if you have thousands of parallel transactions, it would be still very efficient. And if you need to update a single field in this JSON field, it would be still very efficient. Just do this. You would be schemaless and profit. You may be thinking, okay, this guy is kidding, but there is alternative. You could be very agile, very database-oriented, and you could use that famous entity attribute value approach, which is very universal. So you can use it with every type of data. You need 3 tables: entity, attribute, value. At some point, you will need another one, because integers, numbers, dates, text, and something like this, you will have attribute type. It would be much easier than change your schema for data which has changed. So it's boring, so just use very generic approach. Then it starts to slow down. You call these entity attribute value and attribute type tables the core of the system, or kernel of the system. Probably you have special people in your team who is only allowed to make changes in those tables or something like this. And then you denormalize the data, materialized views, extra tables, you populate data there to make it work at least for milliseconds. That would be good. But after that, if it's not enough, you can always add versioning there. So every value could be versioned, and that would be incredibly performant. So do it. Entity attribute value is so popular, one and every commercial software at some point tries to do this. So why not? Try to create as many indexes as you can. Indexes consume no disk space. Indexes consume no memory. There is no any overhead on DML operations if you have 20 indexes on a single table. Optimizer will choose this index because you created that. You remember this. So there is no other ideas here. So if you create index, Optimizer would use it.
Vacuuming will not like more indexes in the table, and more indexes, less probably you would have hot updates that can increase a lot of things. So
it's a nice addition, actually. I need to put that. Your hot updates will profit. Yeah, thank you.
more indexes
Yeah.
for vacuum is
Yeah, and updates. So updates would be quite good. Yeah, there should be not now indexes as well. Well, keep calm, create more indexes. Even if you want to back up your database, because it's worst practice talk. We are speaking about backup. It's like, it's against the rules, Use replication as backup. Use pgdump. Use operating system snapshot. There are tons of good stuff to make your backup never restored. Write your own backup script. It brings extra complexity. Complexity is the key word to successful backup and recovery. And remember, never ever perform a test recovery, because it's the only way how you can verify your backup. You don't want this. This practice would be too good. Turn auto vacuum off. Well, this presentation could consist from one slide, It's auxiliary process. You can easily stop it, and it's very annoying process. It's always there. It runs. It runs and runs and runs, and it's very boring. There is no problem then you have 100 gigabytes data in database which is 1 terabyte of size. Everything else is just outdated things. Large amounts of memory are cheap. I/O is fastest thing in Murdo kernels. I/O is like brilliant thing. It's always very fast. And besides of that, I never heard actually of people who go to a conference and said, we have like 2 megabytes of data in our database. We like low data. Everyone likes big data, because big data make you feel like, oh, I'm powerful. I have a lot of data. So big data is like a very good thing. Always keep all your time series data since the founding of your company, because business always have to have all the raw data. You query that constantly. So never ever put it that somewhere on the disk and aggregate the data. You always need everything. And big data, as I told, big data is good. Big data likes you. It brings you more challenges, and so on. Well, sometimes you can finally use partitioning to get rid of that amount of stuff. But in this case, remember, use very small partitions, like seconds, minutes, month. It would definitely help. Postgres likes when you have 10,000 partitions. Optimizer works perfectly. Just do it. Reinvent Slowney. Who knows what Slowney are? Yeah. So it was an ancient way to replicate Postgres. Trigger-based, with manual configuration. What can possibly go wrong? But very powerful, actually. You need to reinvent them. So use your own replication system. script in Python, log shipping manually, trigger-based would be perfect. That gives you a chance to run into one and every problem Postgres community faced since we implemented Sloaney. So all the way of replication, logical replication, you will experience yourself. That's a good thing to try the history, the heroic history of PostgreSQL project yourself. So do that. Keep primary and replica on different hardware, because then it would be emergency and you make a failover. That's a key factor which allows you to spoil everything. So just do it. Your failover would be unsuccessful. And to make things worse, don't touch primary related things in the configuration file on replica. So no shared buffers, nothing. You always will remember to change those parameters, then you fail over. 100% guarantee. Put your synchronous replica to remote data center, because synchronous replica, it's about better things. So if you have finances, money, or something important to your database, synchronous replica means everything would be OK, especially high availability. You put it into another data center, and if something happens, your entire cluster is in danger. So why not? Just do it. Yeah. That's a good idea. Never ever use foreign keys. Consistency control and application level, I've heard that many times that it would be perfect. And you can never check if something fails, because it's much more harder to check than you do not have foreign keys. You will never get any inconsistency. To be completely honest, foreign keys is a special mechanism in databases implemented to control consistency. That's the main reason not to use it. It's a special mechanism designed for the purpose. Never use it. So basically, if you have special mechanism, never. That's a rule. Always use text type for all columns. Because, basically, you can put figures in text or something like this. You will never ever mistakenly convert something. You can validate IP addresses, dates, time zones. That would work perfect, and you will get interesting things in your code. All this use improved fork of Postgres, because those hackers are old, boring, annoying people. They are developing PostgreSQL for 20 years, more than 20 years, and they just not implement your favorite feature because they are lazy and grumpy and so on and so on. Just patch that on the fly, put it into production, or use a vendor who brings you actually an emergency patch or something like this, and you will end up with a fork, improved fork, and at some point to merge to mainstream Postgres, you only need like 10,000 merge conflicts to resolve. That makes things interesting. So use unmaintained PostgreSQL. It would be better. Forks are better. Marketing of one and every company which produces a fork of PostgreSQL says here, our fork is better than Postgres. You always need to believe in things marketing says. Postgres likes long transactions. It's multi-version concurrency control database, so by definition it likes. All these call external services from storage procedures, like sending emails or working with remote queries. That's arguable. I do that from time to time. But to be a good practice, most of software developers should know the concept of timeout. And many people do not know this concept. So it's a good worst practice. Anyway, you can just test it. So basically, there's Thursday? Thursday is too early. Tomorrow on Friday, just say begin in transaction in your production database and go away, drinking beer, enjoy weekend. On Monday, you will be most demanded professional in your company. They should learn your telephone number, Test-driven development first. Write a query, test it on your laptop, because everybody does this, and it would work with those 10 rows. And, well, if it works, everything is good. Never ever test it in production. It's too dangerous. Not only Slowney should be reinvented. Need to convert timestamp. Write library in C. You're laughing, I saw that. So basically, case, switch, and so on, and then people just use pgdump, and it doesn't restore. Why? We have a special storage procedure. For what purpose? To convert timestamps. OK, never ever use a message queue. Select for update. Postgres likes those things. Who tried to implement this? Honestly, I do that 3 times, I believe, back in time. Won't use ORM, because ORM is worst practice. You learned this. Write your own. PGCQL would be a good candidate to implement this. So it would be good. Interpreting language, perfect. Never use PGSQL exceptions, because I don't know, probably it's the most known part of a PostgreSQL documentation. There is a box there saying that exceptions are slow. Never ever I saw people actually read documentation that carefully like at this part. And, well, you know, exceptions, they are bad things. So just raise notice or just suppress the errors. Who cares? Something goes wrong, your program keep illusion of the proper execution. Keep an illusion is a good thing, so just do it. And besides of this, other exceptions are bad as well. If you're working with your database from your favorite programming language, you know, all abstractions, DAOs, and drivers are smart. They realize if it committed, aborted, or rollbacked, and so on. Never bother to use exceptions around the work with databases. Better suppress them. Because transaction never abort, why rollback, always commit. So you do not need any logic behind those things. And again, if you have those annoying errors, just suppress them. You do not supposed to work with them. So my advice, do not use exceptions. Application runs out of the connections. Increase the max connections. Because, you know, servers with thousands of CPUs are common. We saw a lot of them here. Postgres workers do not have any overhead. Light-weighted logs, memory context, forget about this. Just thousands, 10,000s would work good. And never ever use connection broker. That's evil, you know. Postgres do not have that out of the box. You're not supposed to use pg bouncer. Always use timestamp without time zone. You save disk space. You create logical bugs, which would be very difficult to find. Generations of your colleagues would be thankful to you. And there are plenty of use cases then you exactly need timestamp without time zone. I always ask people when I found this in database, what is your use case? Why you use timestamp without time zone? And yeah, many people trying to answer. Always start tuning PostgreSQL from some strange parameters in PostgreSQL.conf. The good candidate could be like genetic query optimizer or something like this. Never ever try from basics. Shared buffers, checkpoints, things like this, it's too obvious. You can leave it by default. You need to tune parameters of optimizer or something like this. That would help you. So that's a quite common practice. Like people come up to us and say, we have a very specific problem with our PostgreSQL. So we need to exact answer. Could you consult us if join collapse limit this or that would be better for this query? We're starting to take a look into this database, and it's like default shared buffers. It's well, no indexes on this table at all, and so on and so on. So and people go up to join collapse limit to tune it. So that's they probably can write the talk like this themselves. Have you heard about a cool new feature in Postgres, which is like you just heard it on conference? There will be plenty of them. Use it in production immediately. Skip the research part of this. For example, you know MVCC Unmasked by Bruce Momjan. He explains fancy things with xmin and xmax. Just build some logic around this, and that would be good. And basically, you know, when I present in this talk, every third or fourth time somebody in the audience says, okay, we used to do this. But we did not figure out that it is recycled from time to time, that at some point we realized that, and so on. Or alternatively, you have nice new mechanisms. So for Oracle compatibility, for people who are migrating from Oracle, since PostgreSQL version 11, we have manual transaction control in procedures. So just go enterprise Oracle way, like an old corporation, full gas. Use begin commit logic, forget about rollback. That's really a nice approach to make your programs understandable, good, and so on. So manual transaction commit, begin commit logic, it's always easy to implement. Only atomic transactions could be better, so just use it. Never ever use graphical monitoring in your database, because you know we are command line people, open source, Unix way. So we do that in command line. We do not need those fancy graphs. That's for, I don't know, hipsters, because you know it's too fancy. But who needs that? Because on graph you see the trend, what is going on last night. And if your boss asks you what happened 2 a.m. last night, you can take this graph and point out, here we have like performance spike in our disks or something like this. Well, it's too good to be worst practice, so never ever use graphical monitoring. Load your data into Postgres smartly. Write your own loader. 100 parallel threads minimum in Java or whatever you prefer. Good idea to bulk update data is to split them into small batches like 10 and wrap into begin commit things. Your deadlock frequency would be like 10 times better in this case. So remember, you probably already learned this from this talk. Copy is the tool specifically designed for this task. So the answer is, don't use copy. It's a specially designed tool. That's enough not to use it. But do not forget, that was worst practice talk. Because at some point I saw people tweeting some slides from this talk, and other people started arguing with them they should not do this. Yes, that's exactly the purpose. So basically we're trying to learn through some irony or sometimes self-irony, to be completely honest. But anyway, this is a worst practice talk. So you can use this under the worst practice license. So take any worst practice and implement it. So no problem at all. You can freely steal this talk. Slides would be published on the conference website, and explain that to your colleagues. Feel free. And if you have some of your favorite worst practice, send it to me. I will include that to the future talks. So thank you. And if you still have questions, you're welcome to ask them. We have a mic over there.
Testing, 1, 2. Okay. If anybody has a question, I'll walk over to you with the mic.
What are your thoughts on the money type for storing data?
First of all, different. Because if you have different data types for that purpose, you can get many side effects, like rounded incorrectly, and so on and so on. And remember, that's a MySQL favorite practice. Use tiny int plus something, something. But never, ever use numeric. Never. That's a bad idea. Oh, text, actually. You can store it in text. This money symbol, like bucks or euro or pound, you can include that there.
And use regular expression.
Yeah.
Next question.
Logical application slot.
Thank you. If you have data coming from different places and case sensitivity is different, so there was a question: what's the best solution on a joining of such data? So case sensitivity will not be a problem. I mean, you can use C-tags, you can use lower function, you can do something else. What's your take on it?
Yeah, well, you can do many things. But actually, I saw very interesting cases. Then people do use such indexes, and then they have some bugs there. Like they compare in the functional index only first couple of symbols and ignore the rest. And that brings very interesting results. Sometimes people do use such comparison. Then someone reinstantiate the new database because they moved to different server, for example, and forget to initialize PostgreSQL database with proper locale, and it's locale C. And this is, for example, some text in German, Chinese, Japanese, Russian, or whatever. And that brings very interesting results. So it's, I would say if you definitely need to join and using like text and convert the things, if you're sure what you're doing, go ahead. But you need to be aware of some extra problems you need to solve. Yeah. But it's a good question. Yeah.
We have time for a few more.
Yeah.
How do you feel about committing inside a trigger?
I like it. Basically, triggers are very specifically the favorite things of database consultants. So more triggers, you can never ever have too much triggers.
Anyone else? Oh, sure.
What do you think about keeping the logical application slot open for days or many days?
Yeah, that's a great thing. That's a great thing because you will have a problem with a database and guaranteed solution. So basically, you know where to take a look. So I'm not joking. On our some troubleshooting internal scripts for DBA on call, this bullet is check logical replication slot if it's open. It's one of the first positions. Logical replication is actually, it's a bad thing that in this shuffle I do not have anything about this, but logical replication is a good source of worst practices.
One last thing. Checkpoint timeout equals to 1 hour.
What?
Checkpoint timeout equals to 1 hour.
Yeah. Why not? You can do it one day.
What do you feel about excessive use of save points?
About what?
Excessive use of save points. Save points.
Save points. Of course, that's the way you slow down your database. So you do not need to use them. They only slow down things. The good concept of transactions in general, it's like it's syntax is sugar which slow down your database. So many people have this attitude towards transactions. So save points as well, yeah.
Anyone else? Okay, I think that.
Having a lot of idle connection
Yeah, idle connections, especially in transaction, that's a good thing. So
Yeah, idle connection is a very interesting thing. So you should reduce your idle connection if you want to increase the TPS.
yeah, of course. But that would be good practice. Too good for this session.
If there isn't anyone else, I think that would be it. All right. Thank you.
Yeah, thank you very much for attending.